Assalamualaikum warahmatullahi wabarakatuh. Kita akan teruskan perbincangan kita dengan soalan nombor 5, question number 5, mock test A, chapter 6, gravitation. Markah yang diperuntukkan untuk soalan nombor 5 adalah 8 markah. Soalannya adalah a rocket of mass 2.8 exponent 4 kg is travelling from the Earth to the Moon. Of masses 6 exponent 24 kg and 7.4 exponent 22 kg respectively. Calculate the gravitational force of the Earth on the rocket when it is 1 exponent 9 meter from the center of the Earth. Let's identify non-value. Now we need to identify this carefully. Okay. So let's say that Earth is M1. The Moon is M2. Saya tak lukiskan bulan kat sini. Okay, so that's the Moon. And the rocket is M3. Now, given that the mass of the rocket, M3, is 2.8 exponent 24 kilogram, the Earth, M1, is equal to 6.0 exponent 24 kilogram, and the Moon, M2 is 7.4 exponent 22 kilogram. Calculate the gravitational force of the Earth on the rocket. So force on the rocket. Force on the rocket by the Earth is directed to the left according to my diagram. Okay. F on Earth by the rocket, F31. Okay. So soalan nombor 1 very simple. We just need to apply Newton's law of gravitation equation. F31 is equals to G M1 M3 over R13 square. And given that R13, the distance between the Earth and the rocket is 1.0 exponent 9 meter. So we substitute all the value. G is a constant of 6.67 exponent negative 11 times 6 exponent 24 times 2.8 exponent 4 over 1 exponent 9 square is equals to 11.21 Newton. Okay. So, jangan lupa squarekan R. Kadang-kala rumus ada R square tetapi kita terlupa untuk squarekan R. Sama ada dalam penulisan ataupun dalam pengiraan kamu tekan calculator. Dan juga perhatikan soalan nak force daripada apa ke apa. Okay. Sekiranya kamu tak perasan, ambil ringan nak membaca, tak payah baca betul-betul, baca separuh jalan saja, maka kamu akan salah soalan ini. Okay, so the answer is 11.21 Newton. Yang seterusnya, soalan nombor 2. Distance between the rocket and the Earth when the gravitational forces on it by both the Earth and the Moon are the same. Given that the center-to-center distance between the Earth and the Moon is 1.5 exponent 11 meter. So now, the distance between the Earth and the Moon let's say it is x, and x is given by 1.5 exponent 11 meter. Okay, so that is our known value for question number 2. Okay, and then we want to find the distance between the rocket and the Earth when the forces on the rocket by both Earth and Moon are the same. So the rocket experiences gravitational force by the Earth. So this is M1, M2 and M3. So F31 to the left, and gravitational force on the rocket by the Moon is F32 to the right. We want to find the distance between the rocket and the Earth are 31 when the force F31, soalan yang beritahu, is equals to F32. Now again di sini we need to apply a slightly complicated mathematical calculation. Okay, kalau kamu lemah algebra, kalau kamu pandai tak ada masalah. Okay, so kita kena masukkan equation G M3 M1 over R31 square. Now, soalan 2 dengan soalan 1 tidak ada kaitan. Jangan pula pandai-pandai ambil 1 eksponen 9 masuk dalam equation. Okay, so soalan, okay, untuk tak nak mengelirukan, R31 ini adalah R31 yang berbeza. Okay, so saya letakkan simbol prime kat situ nak menunjukkan bukan sama dengan soalan nombor 1. So, that is equal to GM3 M2 over R32 square. Okay, so cancelkan nilai G, cancelkan nilai M3, and we end up with M1 over R31 square is equals to M2 over R32 square. Okay, so kita nak cari R31, kita tak nak R32. Now, from this diagram yang saya sudah lukis, kita boleh nampak bahawa R32 is equals to X minus R31. Okay, then we can substitute this equation into our main equation. So we end up with M1 over R prime 31 square is equals to M2 over X minus R31 square. Okay, so I like to rearrange this equation. So I have M1 over M2 is equals to R prime 31 square over X minus R31 square. And then I don't like the square, okay, because we want to find R31. Okay, so susah kalau ada square. So I square root both sides. So the equations become M1 over M2 is equals to R31 square over X minus R31. Sorry, square dah tak ada. Okay, square dah tak ada because we square root both sides. Okay, so daripada sini kita boleh masukkan value untuk dapatkan R31. Okay, so kita akan ada square root of M1 is mass of the earth 6 exponent 24 over M2 is mass of the moon 7.4 exponent 22. That is equals to R31 over 1.5 exponent 11 minus R31. You solve this equation to find R31 and you get the distance between the rocket and the earth when the forces by the Earth and by the Moon are equal. R31, the distance is 1.35 exponent 11 meter. So that's the final answer for question A2. Okay, so panjang lagi perbincangan kita. Okay, so mari kita tengok markah dulu untuk setakat ini. Markah untuk soalan nombor 5 adalah 5 markah. Markah yang diberi adalah ganti jawapan unit. Okay, pada soalan A1. Pada soalan A2, kita ada 3 markah. Okay, markah yang pertama adalah pada konsep dan kemudian ganti jawapan dan unit yang betul. Okay, so selesai sudah 5A2 dan 5A. Okay, keseluruhannya kita akan bergerak pada soalan nombor 5B. Okay, so soalan nombor 5B. The gravitational field strength at the surface of the Earth. Gravitational field strength at the surface of the Earth, G is equals to 9.8 Newton per kilogram. Okay, ini ataupun biasa kadang-kadang kita cakap 9.8 meter per second square. Ini unit lain bagi meter per second square adalah Newton per kilogram. Okay, diambil daripada definition gravitational field strength, force over gravitational field strength, force over force per unit mass. Okay, so soalan dia, if the Earth have mass m and radius r, okay, calculate the gravitational field strength at point P. Okay, so diagram is very important. That point P is at a distance 2r above the surface of the Earth. So from the surface to point P is r. Okay, so we want to find the gravitational field strength AG at point P. Okay, so yang tadi ni AG on the surface of the Earth, kadang-kadang simbol dia pada topik-topik yang lain kita gunakan simbol G. Pada topik 6 kita letakkan simbol AG on the surface of the Earth. So kita nak cari AG at point P, gravitational field strength at point P. Now, the gravitational field strength on the surface of the Earth, AG, is given by equation G times m over r square. Okay, that r is the distance between the center of the Earth and the surface of the Earth, and mass m is mass of the Earth. Now, that value is equals to 9.8 Newton per kilogram. The gravitational field strength at point P is equals to G times mass of the Earth over Rp square. Now, Rp is the distance between point P to the center of the Earth. Okay, so tadi saya ada tersilap. Okay, soalan dia kata point P is 2r above the surface of the Earth, so this should be 2r. Okay, now from the diagram we know that Rp, the distance between point P and the center of the Earth, is equals to 3r. We substitute that into our equation. G times m over Rp is 3r square. Okay, and we end up with G m over 3 square is 9 r square. This Gm over r square is equals to 9.8 Newton per kilogram. Therefore, AG at point P is 9.8 over 9. And you'll get 1.09 meter per second square. So that's the answer for question 5B1. Question 5B2. What is the weight of an object with mass 3 kg at point P? The weight is equals to mass times the gravitational acceleration. So 3 times 1.09 meter per second square or Newton per kilogram. Okay, so tekan calculator, substitutekan that value. Okay, we already substitute the value, and the answer for weight is equal to 3.27 Newton. Okay, so that's the answer for question B2. Okay, so markah di sini cuma ada 3 saja. Calculationnya pun sebenarnya mudah. Okay, so markah dia ada pada gantian jawapan dan unit yang betul, sama ada Newton per kilogram ataupun meter per second square. Dan kemudian di sini we have jawapan dan unit yang betul. So that's all for question 5. Thank you for watching. So kalau ada yang tak ingat, bolehlah angkat tangan semasa kamu dengar video ni, ataupun ada yang tak faham boleh tanya saya semasa kamu dengar video ni, kerana kamu dengar video ni dalam makmal. Okay, so itu saja. Assalamualaikum.